So type is the nothing but the number of an integrator present in the system, that is called the type of a system. We will discuss in the further. Now if we talk about the closed loop system, so closed loop system is what? An open loop transfer function of a unity feedback is nothing but the closed loop system. Okay, open loop transfer function of unity feedback system is the closed loop system. मतलब कि अगर open loop transfer function है जिसमें हमारा जो फीडबैक है वो यूनिटी होगा, मतलब hs equals to 1, that is called closed loop system. Okay, where gs equals to gain equals to q1 plus s tau 1 into 1 plus s tau 2 upon s का पावर n 1 plus s tau a 1 plus s tau b. ये है. इसमें क्या होता है, टाइप क्या होगा, नंबर ऑफ ओपन लूप पोल्स. क्लोज लूप नहीं होगा. एक्चुअली में क्या है, टाइप सिर्फ रिप्रेजेंट करता है ओपन लूप सिस्टम का. ओके, इसमें जो है टाइप भी होगा, ऑर्डर भी होगा. इसमें सिर्फ ऑर्डर होता है, एक्चुअली में टाइप नहीं होता है. लेकिन जो टाइप अगर फाइंड करते हैं तो वो टाइप क्या होता है, इट इज द नंबर ऑफ ओपन लूप पोल एट ओरिजिन इन द फॉरवर्ड पाथ, दैट इज द ट्रांसफर फंक्शन hs_f1. नंबर ऑफ ओपन लूप पोल्स का फाइंड करना पड़ेगा. इसमें टाइप निकालना होगा, दैट इज द नंबर ऑफ ओपन लूप पोल्स एट ओरिजिन इन फॉरवर्ड पाथ, एंड ऑर्डर इज द नथिंग बट टोटल नंबर ऑफ क्लोज लूप पोल्स इन द क्लोज लूप सिस्टम. हियर अगेन सेम फॉर्मूला, total number of open loop poles, here total number of closed loop poles. Here if we talk about the open loop, then it is open loop pole, total number of open loop pole. If we talk about the closed loop, then it is the total number of closed loop poles. Now you will see one problem based on the open loop and open loop transfer function. Let's see how to solve this problem. Hello. So in this session we will see the type and the order of the open loop system and the closed loop system. So let us first talk about the open loop system. So what is an open loop system? Open loop we have already discussed. Any system described in the form of open loop transfer function, that is called ओपन लूप सिस्टम. कोई सिस्टम जिसको हम ओपन लूप ट्रांसफर फंक्शन में रिप्रेजेंट कर सकते हैं, दैट इज ओपन लूप सिस्टम. हियर इट इज any cs by rs equals to k1 plus s tau 1 into 1 plus s tau 2 dash upon s and power n 1 plus s tau e into 1 plus s tau b, where k and t, where k, this is the system parameter k, and tau, okay, this is tau, k and tau are the system parameter, and here in denominator there is n to the power s. Okay, that's the type, it's represent the type. So type is nothing but type of an open loop system is the number of pole at origin, number of pole at origin in open loop transfer function. Okay, मतलब टाइप क्या होगा ओपन लूप सिस्टम का कि ना कितना ओरिजिन पे पोल है. Okay, number of pole at origin in open loop transfer function, that is nothing but the type of an open loop system. Okay, order, again second term, it's an order. First one, the type, very important. We'll see numerical problem based on the type of an order. And this is, second one is the order. So total number of an open loop pole in open loop transfer function, that is called an order. तो यहाँ पे origin पे कितना pole है open loop transfer function में, that is nothing but the type. And here order मतलब number of open loop poles कितना है ना, open loop transfer function का, that is called order. वेयर के क्या है हमारा ओपन लूप गेन है, एक्चुअली में के हमारा ओपन लूप गेन है. अब सिमिलरली देखिए कि जो टाइप एक्चुअली में इट्स रिप्रेजेंट, इट्स ओनली फॉर ओपन लूप ट्रांसफर फंक्शन, इट्स नॉट फॉर क्लोज लूप ट्रांसफर फंक्शन, एंड द नंबर ऑफ इंटीग्रेटर. Hello everyone, this is the we are going to discuss the characteristics equations. So cs upon rs equals to gs upon 1 plus gs into hs. Characteristic equation is nothing but the denominator of the transfer function make an equation equals to 0, then it's called characteristic equation. the denominator of the transfer function when it's equivalent to 0, that is called transfer function. Okay, gs into hs. Okay, let's multiply. Okay, equals to transfer function. Okay, now let an example. Actually, it's helping finding the behavior of the system. Behavior is, that means whether a system is exponential, decaying, or constant. This type of behavior will just come to know after just go through the characteristic equation. Like we have taken an example like Cs upon Rs, output upon input equals to S plus 1 upon S plus 5 into S plus 10 equals to A upon S plus 5 plus B by S plus 10. So impulse response is nothing but what? This, let's say this. Impulse response is also transfer function. No? We have already seen in the previous lecture, transfer function of the LTI system is nothing but the impulse response of that function. Okay, and this is given by, let us assume A, instead of A is K1 and B is K2. Again this equation, and from S domain to time domain we will get this equation. And if you want to draw the equation, that exponential, if you want to calculate the value, that means exponential minus 0 is how much? Anything 0 itself, na? No. Exponential to the power 0 is actually 1, and 5t is there now. So exponential minus 0 is again 0 is 1. Okay, and for exponential minus infinity is 0, for both 0. So we can say that equivalent value of this is maybe like here k1 plus k2. Okay, and for the infinite value of t time, maybe let us assume it is ct, it is t, then it is infinite, maybe it's decay. Why it's decay? Exponential decay, because here exponential decay, and that's why. Okay, so actually the characteristic is 1 plus gh, this is 1 plus gs into hs is the characteristic equation. Okay, that is used to find the behavior of the system. And you know the root of the denominator of the transfer function is the transfer function, and the root of this denominator is known as the poles. Poles is nothing but the root of the denominator of the transfer function is called pole, and the root of the numerator of the transfer function is called 0. Okay, now let's see an example of pole and 0. See here, the system is given equation k1 plus s tau 1 into 1 plus s tau 2 upon 1 s n power n s ka power n into 1 plus s tau a into 1 plus s tau b. So if for calculating the value of pole and zeros, we just have in this format s plus 1 by tau का form में रख दिया. So find the value of this, or here we can also find, if we equate it to 0 now, then what we get? 1 plus s tau 0, s tau equals to 1, and s equals to 1 by tau. Okay, so this is the actually the poles and zeros. Okay, this is the pole, and upper numerator, the root of the denominator of the transfer function is what? Nothing but pole. The root of the denominator of the numerator of the transfer function is called 0. So the poles and 0, we can see that the poles and 0 are nothing but the negative of the inverse time constant. This is the time constant, not t1, t2, t8, tb. So inverse negative, negative inverse of this time constant is nothing but the poles and 0. Now let's see what is time constant. Of course, so time constant is nothing but it's the give the speed of the system. Time constant agar bahut zyada hoga, if it is very large, then it is called slow response system. Why? Because it will take the time constant to reach the steady state. Okay, ग्राफ बनाते हैं कि अगर यहाँ से जा रहा है यहाँ स्टेबल होने में इसको बहुत टाइम लग रहा है, इतना टाइम कांस्टेंट है ना, टाइम कांस्टेंट ये 5 टाउ पे मिली स्टेबल हो जाता है सिस्टम. सो टाइम कांस्टेंट जितना अच्छा रहेगा, अगर तुरंत ही स्टेबल हो गया तो बढ़िया, 2 ही पे हो गया, 2 टाउ पे, यहाँ 5 टाउ पे हो गया. So it's give the speed of the system in. Time constant are very large, then it's called slow response system because it's take the large time constant during the steady state. Okay, practically कोई भी system gives 5 tau. Okay ना, 5 t tau constant to reach the steady state practically. And time constant is given by negative minus 1 upon the real part of dominant pole, real part of dominant pole. We'll see what is dominant pole. So it is nothing but the real part of the dominant pole. Now see what is dominant pole. Now see what is dominant pole. So dominant pole is nothing but the pole which is close to the imaginary axis, which is very nearest to the imaginary axis, is known as the dominant pole. And insignificant pole is the pole which lies in the leftmost side of the imaginary axis. Okay, leftmost side of the, that is the negative portion. Okay. Now one question is there. One question is there to find the equivalent lower order system to the given transfer function. One transfer function is given, Cs by Rs equals to 1 upon s plus 1 into s plus 10. So we have to find the poles. So what, suppose finding the poles in 0, we have to, for finding the poles, what we have to done? The question is, find the equivalent lower order system to the given transfer function. Find the system time constant. Find the equivalent lower order system. So Cs upon Rs equals to 1 upon s plus 1 into 1 plus 2. Now for finding the pole, we have to just equivalent the numerator, not numerator, numerator is for 0. So denominator, this denominator is to be 0. Okay, now get s plus 1 into s plus 10 equals to 0, where s equals to minus 1 and minus 10. So tau is nothing but minus upon dominant pole. If we have plot on the x-axis, it is imaginary axis, it is a real axis, it is a real axis, it is imaginary axis, negative, negative, positive, and it is positive. Okay, actually it is j-axis. Okay, not j, it's actually j-axis. Okay, now see that s equals to s plane, it is actually s plane. So minus 1 we're somewhat here, and it is somewhat 10. So which is, it is minus 1 minus 10, it's not 10 is not working. So minus 1 minus 10. Okay, so which is nearer to the, close to the imaginary axis, this one, so it is dominant pole. Which is leftmost side, that is the insignificant pole. Okay, it is said that, so what will be tau 1? Tau is nothing but the dominant pole. Minus 1 for negative 1 upon dominant pole, that means minus 1 equals to 1. So tau is 1 second. Okay, tau is 1 second. It will take 1 second to reach the steady state. Okay, signal will reach the steady state. Now there is some notes that insignificant time constant is less than or equals to the dominant pole tau by 5. So it is less than equal to dominant pole of 5, that means IP is less than equal to dominant pole theta by. Okay, this is nothing but the imaginary pole. Imaginary poles is neglected. Why it is neglected? Because even if there is no much changes, in fact it doesn't have any changes on the system itself, very leftmost side, that's why there is no any more effect on the system, that's why we eliminated. Sometimes we have this thing. Insignificant pole gives fast response, but due to dominant pole, of course the fast response, poles give fast response due to dominant pole, which is very close to the origin. Pole which lies close to the imaginary axis affect the stability of the system. Okay, so the pole which is very close here to the origin is more stable, more stable. Marker is not working. More stable, close to origin. Okay, so for tau equals to minus 1, it is very close to the origin, that's why it's more stable. Okay, now there is one question is to find the system response for which the input is given R is equals to 1. Now let's see. Now see, we have to find the system response. Okay, the system response is what? What is system response? System response is nothing but the response, the effect of the input on the system. The resultant is known as the system response. कोई भी सिस्टम है उसमें जो हम इनपुट देते हैं, इनपुट आफ्टर गिविंग द इनपुट, whatever the input is, what excitation and the output comes from system is known as the system response. Okay, So it's asking question regarding the system response for which the input is 1. So CS upon RS transfer function equals to 1 upon S plus 1 into 1 S plus S plus 2. Okay, we can write as CS by RS equals to A upon S plus 1 plus B upon S plus 10. Okay, and if we substitute this one, solve, then it is A into S plus 10 plus B into S plus 1 upon S plus 1 into S plus 10. If we solve the for the value of A and B by putting the value equals to 0, then we will get, let's solve, S plus 10S 10A plus BS plus, sure, here RS is 1 now, so put the value of RS, so CS equals to 1, so it is 1 only, 1 by S square plus 11 plus, okay, okay, new. We have this one, we need this one, because if it equals to 0, then what? 0. If S equals to 0, then this 0, then this 0. Okay, that means 10. If we calculate that for S, AS plus BS plus to 0, solving this, we will get oh sorry, it is given a 1 now, so it is equals to 1. So now we calculate B. Calculate B will get B equals to, so now impulse, so after solving what will you get? This one you get 1 by 9. Marker is not working, let's change the marker. So see here, after solving we will get B equals to minus 1 by 9 and A is 1 by 9. So after substituting this value we will get, this is for dominant because S is equals to minus 1. Minus 1 is very close to the imaginary action, and here S equals to minus 10. So this is imaginary, and this is dominant. This is imaginary. Okay. Now, so see there. Actually, यहाँ पे Laplace of the exponential minus at equals to 1 by S plus A. उसको जब हम ग्राफ बनाएंगे तो it is minus 2 in the negative axis of the imaginary part. So this is the negative axis. Now for sin A and cos B, sin A equals to B upon S square plus B square. Where S equals to minus B plus minus. Here minus B plus minus. This is for S also same. For exponential minus 18 to sin BT is anything but B upon S plus 1 square plus B square. For sin this one, and for exponential term this is the again 40 and exponential minus 80 equals to n factorial upon SL plus 1, where n plus 1 is the pole. Okay, so it is there. So finally what we have concluded that the response consists of whole terms. Okay, response consists of the whole term only. Okay, we'll tell only the exponential power or real part of the pole. Exponential power or the real part of the pole. Exponential minus 80 here, minus 80 here, minus 80. So they are the real part of the poles. Sine and cos functions are nothing but this sine and cos are nothing but the imaginary part of the pole. So it is here, and for exponential it is here in the real, and for sine cos it is imaginary. Okay. So for finding the time constant, we have to compare with the term exponential minus t by tau. Okay, to every response. Like in the previously, what we have got ct equals to 1 by 9. Exponential ct equals to 1 by 9 exponential minus 80 minus t actually, and minus 1 by 9 exponential minus 10t, okay, by ut. If we compare with this one, exponential minus t2, then it is exponential minus t by tau, and this one exponential t. So that means tau equals to what? Minus 1. It is 1 second. Actually, it's 1 second. 1 second, and for this also same parallel tt. So tau equals to 10 second. So this is the remnant, and this is the remnant, and this is nothing but the imaginary pole. Okay. Now to get system time constant from response, compare the response with exponential minus t by tau. The system tau is 1 and should be the largest. Instead of the largest, it should be always less than 1. That means very less and should be the largest value. Okay. Now we will discuss in the next chapter, in the next session. Okay, today that's enough. Thank you.